right, so we are going to wrap up chapter 2 today. Means on Wednesday we will have the test. We'll cover all that in just a minute. Alrighty, so it is 9:28 today. So we got 9:28, and this is going to be Chem. 11:10, chapter 2. Review. Alrighty, so here is my 3x5. And again, what I do is I go through the test, and every topic that is on the test is on that 3x5 right there. Okay? So we're going to go down through this. I will give us an opportunity to answer to ask some questions, and then I will give you some time in class to hopefully improve your homework score. Even though I'm sure you're not the only one. I haven't pulled up your classes yet, but I will. So, okay? Alrighty, so first thing I've written down is make sure you use the periodic table. And the reason I say that is because there are probably 6 questions that are directly off the periodic table. Okay? Like something I wrote down right here, I wrote P does not equal K. Anybody know what I mean by that? Yeah, P is what? No. P is phosphorus. Okay, K is potassium. And you giggle at that, but I can't tell you how many kids are going to miss that kind of question, even though it's right in front of you. Make sure you pay attention, okay? So make sure you use that periodic table, okay? Make sure you understand the difference between a shell, and sometimes they call it shells. Anybody remember what else I call a shell? A subshell. That's 2 L's. A subshell and an orbital. A shell is also called an energy level. And that's what I call it a lot. Okay? Now, when I'm talking about this, when they use the word orbital, and they'll ask you a question like how many electrons can be, this was right off the homework in one of my last questions. Or in my last class, it said something about like how many electrons can be in a 4D orbital. What's the answer? How many? 2. 2. Orbital is 2. Now, if it said the group of 4D orbitals, now the answer would be what? 10, right? Because that's the subshell. That is the S, the P's, the D's, and the F's. And that depends. So if I'm an S, how many electrons can be there? 2. A P is, a D is 10, and an F is 14. Now, shells or energy levels, this now depends on what? The period it's in, right? Because the period determines shells or energy levels, right? And that really can go from 2 up to, what was the highest? 8? It actually goes 2, 8. Anybody know? We did this one day. 18. What was the highest? 32. They would be the options there. Okay? First shell, second shell, third shell. That is 4 shell and above. Okay? Alrighty. So now I've written down this. I've written down isotope symbols and how to get the numbers. Now, I actually covered this twice, which means there must be a couple of questions on this, because down, like third line up on my thing, I wrote this. I wrote rewrite, and these really go together. So it says rewrite and answer the number of neutrons and then I wrote this. I wrote germanium 70. So how would I rewrite germanium 70 in the other way? Because this is one way they write an isotope. What was the other way? Yeah, so what would germanium 70 look like? First off, I got to know its letters, right? So what are the letters for germanium? So I got GE. What's my superscript going to be? 70. What's my subscript going to be? 30 what? 32. How do we know my subscript was 32? Because that's it's what? You're right, it's the number of protons, but what was that called? That's my atomic number, right? That is my atomic number, and that is the number of protons. Okay? What was the superscript?
That is your mass.
That's my atomic mass, and that is the what? Protons plus neutrons, right? So my question said, rewrite and answer the number of neutrons. How would I find the number of neutrons in that?
70.
Yeah, I just go 70 minus 32, and that's going to give me 38 neutrons like that. Okay? Is that, I mean, I think we've talked about that a couple of different times, haven't we? Yeah? Okay. So that is that. From there, we went to, I discussed areas of the periodic table. Now, they do this several ways. Okay? It's like if I wanted someone in here to say, okay, name one area of the periodic table. Anybody name an area? Okay, so if I said, where are the metals at? Left of the steps, right? If I said non-metals, they are right of the steps, right? What if I said transition metals? Now, this is the transition metals, right? That's an area, okay? What if I said inner transition metals? Yeah, they're down here, right? Now, could I say noble gases? Yeah, they're right here. If I said halogens, you know what I'm saying? There's lots of difference. Is there another way I could label that area besides transition metals? They also represent the D's, don't they? Just like that area represents the P's, and that area represents the, and that area represents the F's. There's a lot of different ways I could look at that. You know what I'm saying? So make sure you understand what is where. Okay, what if I just said that group? Yeah, and then if I said that group, that is the alkaline. So it's just things like that. You've got to be able to know where they're at. Because they'll say, you know, it'd be something like, how can I identify sulfur? Well, sulfur is a non-metal, right? But it's also a P. So there's a lot of different ways I could do that. So make sure you read the question and answer it. A lot of times, if you're not sure, look at the answers they've given you, and you'll say, oh, they must want that. Yes, Bella?
Can a non-metal be a metal like?
Yeah, so like anything, these two, germanium and antimony, they are the two that they list in the book as being, oh my hell. It literally just left me. As metalloids, thank you. Yeah, metalloids. And then those 5, okay? Actually, those 6. 1, 2, 3, 4, no, 5. I was right. So there should be 7. Okay? So just make sure you understand the areas. Okay? All right. The next thing I asked is this. What do protons, neutrons, and electrons do? Okay? I know we've talked about this. What do protons do?
Gives your atomic number.
Okay, atomic number. What else? But what are the one thing protons do the most? Say out loud and determine what it is. Determine what it is. Neutrons are responsible for what? They add mass. But they also do what? Isotopes, right? And then electrons. Yeah, so what was the 2 words I used the other day? Anybody remember? I used 2 specific words that I said came out of the book. I heard it. What was that? Was that you, Bella? Chemical reactivity. Okay? And they're also responsible for what?
Your ions.
What?
The ions.
Ions. Responsible for ions. Which I believe is something we talked about the other day, didn't we? Okay. Alrighty. From there, we talked about trends on the periodic table. So when I talk about trends, what do you think I'm talking about? Anybody remember? Talked about 2 different trends. What were they? Ionization energy was one trend. What was the other one? Size, right? Now, someone in my last class say, is size and atomic radius the same thing? Yes. The higher the atomic radius, the bigger it is, right? So, understand that if they're going to compare them, remember how we talked about comparing things? They are not going to be gray. They're going to compare like bromine and krypton. So if I said, which one has the highest ionization energy between those 2, what would you say? Krypton. Which one's the biggest? Bromine's the biggest because it's closest to that, right? They get smaller. They get smaller. And they'll do that. And then they do it like these 2. So it'll be really obvious what the answer should be. Okay? They won't do like these 2. Okay? All right. Set as trend, size, and ionization energy. Oh, okay. Periods versus groups. Periods versus groups. Okay? Now, periods are the what?
The rows.
These are rows, right? Groups are columns. Now, I had a girl come in this morning and ask me a question, and I thought this is perfect for this class. She said she had a sister go in and get surgery. And before they cut her open, what do? Anybody know? Right before they operate on you, what they do? Yeah, but after that, sometimes before that, I guess, they cover you with some kind of brown stuff. Anybody know what that is? I heard it. Iodine. Okay. Do you know what iodine is?
Doesn't that like sterilize it or something?
Okay, iodine is you're right, what would they call that? Let me know what they call it. Antiseptic, right? Now, antiseptics are anti-what? Do you know? Antibacterials, right? So they kill all the bacteria there so the bacteria doesn't get where? Inside your body, right? Now, she wanted to know what it did and why it did that. I thought, okay, this makes perfect sense because what do they do with chlorine? Does anybody know what pretty much every city in the country does with chlorine? Besides pools, you're right, they do it in pools, but something that affects everyone. I heard it. Who said that? Yeah, they put it in your drinking water. Why do they put it in your drinking water? To kill bacteria, right? It's what kills bacteria. That's why they put it in pools, is to kill bacteria, right? Well, it makes sense then that iodine would also be used to kill bacteria. Does anybody know why? Same group, and what do we know about things that are in the same group? Not the same, but they act similar. So if chlorine kills bacteria, it makes perfect sense that iodine would also then kill bacteria. Okay? And really anything in that group would kill bacteria because they all behave similarly. Okay? So just remember that groups, which are columns, groups are similar chemically. Okay, similar chemically. Alrighty, now, electron configurations. Sometimes you will hear them called orbital diagrams. Now, they do this a couple of different ways, okay? Electron configurations are typically the stuff, and we've done both of these, but electron configurations are the whole what? What does an electron configuration look like?
Oh, the dots.
No, that's the electron dot.
That's the orbital.
Yeah, so it's like 1s2, 2s2, 2p6, 3s2, yada, 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 right? The only difference between that and an orbital diagram is the orbital diagram, they usually draw the boxes with the arrows in it. Okay, these are the same thing, but they usually draw, when they call it an orbital diagram, they draw it, you guys know, we did do some of these, right?
Yeah.
Yeah, they'll do, you know, something like that, whatever, okay? They call it an electron config, then they'll do it like this, even though these are really showing, I mean, these two aren't, but they're describing the same thing, okay, where the electrons are in there. Something that I just realized I did not show my last class because I felt it was easy, but I probably ought to bring it up here, are Lewis dots. Do we need to do a Lewis dot structure? So if I wanted to do the Lewis dot of oxygen, what would it be?
6 dots around.
Say what?
6 dots around.
6 dots around it? So I would go 1, and how do I do that? Anybody remember? Yeah, star pattern, right? 1, 2, 3, 4. What about the other two? Really, anywhere, but typically they do them like that, right? Okay, something like that. So make sure we know how to do Lewis dots. Now, I want to say there's a couple of them. I think there's a couple of them on the test. So that should be like, in my opinion, 2 gimmies. Okay? So, and then we already did that one. My next line says rewrite and answer the number of neutrons for germanium 70, but I already covered that, right?
Yeah.
And did we talk about why iodine and chlorine behave similarly?
Yeah, we just did.
Because they have the what?
The same.
Same. You're right, but that means they also have the same what? Say that louder. Same, what's the word for that? Starts with a V. The same valence, right? Because valence is responsible for my chemical reactivity, right? So group, this is what I have written down. I have group equals same valence. Okay? And then, I think we already covered this one too, right? Didn't we do my last line already? Isotopes equals different number of neutrons. Ions equal different number of electrons. Did we cover that yet? No? Okay, so isotopes. Yeah, we did. When we did protons, neutrons, and electrons, didn't we? And yeah, right here. Neutrons responsible for isotopes, electrons responsible for ions. Did we talk about that right there? But that's all right. Okay. All right, now what I want everybody to read, if you can. I think I did a little better job of writing this down. Is there anything there that is something we've not talked about? Because this is every topic that's on the test. Yes.
Learn smarts or something about like electron valence configurations, and they're a little bit different than the electron.
Okay, so that was like, so here's a great one. So let's do this. Let's go raisey handy. I will tell you this though, Patel. No. Yeah, Patel, right? Shiv, correct? Now, if I do not talk about it today, what do you think that tells you? It's probably not a specific question on the test. But this is still a good question. So let's do this. Let's go raisey handy, because we were going to do this once anyway. Let's say I wanted arsenic. I want to do AS. AS is number 33. Okay, I want everybody. Let's go 15 hands for the electron configuration for arsenic. Okay? I need 15 hands before we go on. I want the electron configuration for arsenic. What? Remember your numbers. If you have to do it, one kid says, I just write my number down right next to the question so I can't forget it. So that is a good idea. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 3 more, 13, dos más, 14, 1 more, 15. Who was 7? You're up.
Okay, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p3.
Alrighty, now, is she right?
Yep.
Okay, there's 2 or 3 questions just like that on the test. Okay, now, to answer Shu's question is this. If I asked you for the valence is what? If I said just valence, the valence is 5 because they're my highest coefficients, and there's 5 there, right? If I wanted the valence configuration, now I've got to draw them just like they're written here. So the valence is 5. The valence configuration would be 4s2, 4p3. You see the difference? That's all it wants. Okay? Yeah. Good question. Anybody else got a good question? Bella.
Can you explain how to find, if it gives you a box configuration, how to find the element you want?
What do you mean?
Like if it gives you the boxes. and
So,
you have to find the elements.
what I do is I just take the boxes and I translate them into this.
I just go to the last box.
Okay, so the other option is this. So let's say I did this. Let's say I had all this crap out here, a whole bunch of boxes, and let's say I did this. Let's say I said my last box looked like this, and they usually told you down here. Let's say that this is my 5D. Didn't write below it. They write what it was, and I said something like I did this. Let's say I did that, right? So what I would have done is I would have said, okay, I know that this is 5D. Well, how many electrons are there? 6, right? So I know that this is going to end in 5D6. So I would have went to my periodic table and said, okay, I know this is D6. So I know this is how many boxes over in the D range. So I go 1, 2, 3, 4, 5. So I know it's got to be right here, right? But I'm in the 5. So what was the first one in? 3, because that's period 4, right? So that's 3, that's 4, that's 5. It must be osmium. Does that make sense? Yeah. Okay. So, and if it's a small one, you can do the whole thing. It just depends. But that's a good way. Is it? Okay. And they're very similar to that on the test. Okay. Anybody else got a good question? Yo.
Can you go over writing isotopes again?
Yeah. So let's do this. So let's say I gave you cobalt 60. So if I gave you cobalt 60, okay, I want you to write the symbol and tell me the number of neutrons. Okay, let's go for 10 hands. I want 10 hands with the isotopic symbol and the number of neutrons. I need both answers, and I have 1, 2, 3, 4, 5, 6, 7, 8, 2 more, 9, 1 more, 10. All righty, who is 5? All righty, Bella, what do you got?
For the isotopic symbol,
Yeah.
capital C, lowercase o,
Okay.
and then the superscript is 60, and the subscript 27.
Okay. And then, who was number 3?
The new number of neutrons is 33.
33 is the number of neutrons. Is she right?
Yeah.
Just like that.
Awesome.
And that is probably another 2 or 3 questions on the test. You're going to fall into that vein. Okay, something about isotopes. So whose question was this? Is that...
Yeah, that was good.
And that's what you're going to see. There's 2 or 3 questions that deal with that portion.
So is it always going to give you like the 60, so like your superscript?
Yeah, you really have to.
Yeah.
Yeah. Unless they said, yeah, let's just stop at that. Because all the ones I would be making up because there wasn't one like it on the test. So it's going to look something very similar to that. You're going to go, oh, this is the problem Mr. Denton was talking about when we went over that. I'll be like, huh, imagine that. How about over here? You guys like real quiet over here. Other than Red, she's been pretty good today. Anybody else? Reynolds, you got anything? Nothing? Nothing? Yo! Wait a minute. Jepson!
Yeah.
Your mom was number 1, by the way.
Number 1 for what?
The first person to sign up for parent-teacher conferences. Good job.
She signed up? Okay.
Well,
Okay.
now you make me all like not sure of myself. I don't know if I have any math Jepsons. I will have to look.
Okay.
But I thought when I saw that, I thought that was you. But
Yeah,
you know,
that was it, actually. For the Lewis dots, on like the example, I just don't know how you got 6.
because it has a valence of 6, right? So I have 1, 2, 3, 4, 5, 6. Because remember, it's just the valence. It can only be up to what? Only be up to 8. So it doesn't matter. So if I did, like, let's say I did boron. So if I wanted the Lewis dot of boron, well, what's boron's valence? 3, which means it can only have 3 dots. What's the only thing I really know about where those 3 dots have to be? Well, but I can't have any that are what? On the same side, right? Because if I've only got 3, it could look like that, right? Now, is that the only way it could look? No, I mean, it could have looked like that. It doesn't matter. What else do I know about, like, let's say, gallium? Look at gallium. What would its Lewis dot look like? It would look the exact same because they have the same valence. I would just have written Ga instead of B. Everything in that group is going to look the same. Does that make sense? It's just whichever what. Who can remember what they were called? What were the first 2 and the last 6 called? Anybody remember? They were the main group, right? So whichever column in the main group it's in, that is its valence. Okay? Is that... I've mentioned that before, haven't I? Main group. We talked about that one day, right? Okay. Is it Olivia?
Yeah.
Yeah, does that make sense?
Yeah.
Okay. Anybody else got a good question? Yo.
So all the transition models just have 2.
2. Yeah, all the transition elements have a valence of 2. Because remember, they go like 5s2, but the next electron's down in the prior energy level, so it doesn't count. Yeah, and I want to say that was actually either a Learn Smart or a homework question, wasn't it? Anybody remember that question? 'Cause I know I got asked it by somebody. Nobody? Has anybody done all the homework?
Yeah.
And there wasn't a transition metal question on there?
There is. There's it gives you 3 elements and you gotta figure out which one's which.
Yeah, so I'm pretty sure that there was somewhere on there. I don't remember one on the test, but could be, I guess. You 2 got a question?
I was just asking when he asked, but I got it.
Okay. Anybody else? Nobody took a picture, did the homework? How many of you have done all the homework? Raise your hands. A few of you. And there's no, no?
I don't remember.
You don't remember? Well, that's not good. We're taking a test. So while I'm at it, think about this. So all homework is due 9/29 at 11:59. Remember, right? That's tomorrow night, 11:59. Okay. Lab number 2 is due before the test. So when you walk in, okay, lab dues. And I realize that Wednesday is a short day, but I mean, we only took a half an hour on the last test anyway, so I wasn't real concerned about time limit. And my last class said that they felt that this stuff was easier. And I'm like, well, okay, hopefully we feel that way after the test. You know what I'm saying? But yeah, there's no reason, because are there any calculations? Really? There's not like dimensional analysis we had to do where we were converting things, right? And what you'll notice is that you're going to read through these questions and you're going to either instantly know the answer or instantly think to yourself, man, I should have taken Mr. Denton's advice and studied harder. Yeah, like I'm serious. That's what's going to happen. Okay? So lab 2 is due before the test. Then the test is Wednesday, and that is 9:30, right? For you guys? Okay. Hopefully so B day, I better point this out. B day is 10-1. Because they're going to be watching this video tomorrow. My wife's getting shoulder surgery, so I will not be here. So, okay. Questions? Yo.
Can I make up the lab like tomorrow after school?
Yeah, you'd have to just come in and do it, though. Because like I said, I will not be here, but yeah, that's fine.
Okay.
Anybody else in this class not get the lab done? Okay, so hopefully someone else, because I know I have like 6 kids that didn't do it because they were absent. I will try to find you a lab partner, but if not, there's plastic gloves just right around this corner, just down from the TV. Wear them. Everything you need's over there. It's pretty self-explanatory. Okay. And then remember, on the lab, people, make sure, and I don't even know how to say this, but remember how the very first day we talked about you should have 2 goals, and one is to get 100% on all your homeworks, learn smarts, and the other one is to get 100% on your what? Labs. If you're not comparing and discussing with your lab partner answers to those last 5 or 6 questions or however many there are there, that's like, let me think, that's like stupid. You know what I'm saying? It's like I had one student in the last lab miss every question, and I'm like, that just doesn't make any sense. Yet their lab partner got 100%. I'm like, oh, that's things that are great things to discuss. You know what I mean? So yeah, I'm not saying just write down there, but that's a good topic to talk about. You know what I mean? So, okay. I believe that's everything. I mean, did we all read through this and make sure that I covered everything that was on there? Because I literally sit down and went through every question on the test and the other topics. Okay? Alrighty, so the time is yours. I would use it wisely. If you're done with the homework, now would be a great time to read some of the text. At least read what we talked about. Highlighted portions, right? Okay. Okay, let's do it. Get busy.